What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to continue our discussion on the distributive property or multiplying binomials together, and we're going to look at what happens if we've got a negative sign thrown into the mix. Does that change anything? Does it not? Let's find out. In the previous videos, we've talked about both the area model and the distributive property, and we're going to do that for both of these. We're going to use both methods for this example of x minus 1 times x minus 1. So just to differentiate these two things, I'm going to call this our blue x minus 1, and I'm going to call this our red x minus 1. So using the area model, we're still going to follow the same process that we've done before. We're going to label this as if we were finding the area of a square or of a rectangle. And we know that the area of a square or a rectangle is length times width. So we're going to consider one of these things our length, and we're going to consider one of these things our width. So our length, again, it doesn't really matter which way you put your length or your width, but we're going to put our x and we're going to put our minus 1 over here. Now, in previous videos, what we've done is we've always had a plus sign in between these two things. But you could do a plus, a negative 1, or you could just leave it as minus 1. The real important thing with this is that you're keeping track that that 1 is a negative value. So that way when you start multiplying, you're keeping track of the negative 1 and you're distributing it properly. The other piece is going to be x minus 1 as well. So again, I could put a plus sign right here if I wanted. Plus a negative 1 is the same thing as x minus 1. So as you like. I tend to just leave it like this and just remember that this is x plus a negative 1. And again, if you've maybe done this using algebra tiles, you might have some different things where you've kind of using a red for a negative and a green for a positive. I think that's the colors that they work out to. But really, for our purposes for this, it's just to keep track of the pieces. That's all the area model is doing. So we're going to take x times x, which is x squared, and that's going to be this first box right here. Then we're going to have x times negative 1, which will be a negative 1x, and that's going to be for this piece right here. And then we're going to have another x times another negative 1, a different x and a different negative 1, but we're still going to end up with a negative 1x, and we'll call that for this piece right here. And then finally, we've got a negative 1 for this dimension and a negative 1 for this dimension. So we're going to end up with negative 1 times negative 1, which is a positive 1. And that will be for our last piece right here. So when I'm adding all of this together, I'm left with x squared minus 1x minus another 1x plus 1. And again, our x squared, our minus 1, our first minus 1, maybe you go there, maybe you go green. You've got your other minus 1. And then you have your positive 1 right there. So when I simplify all of this together, I'm getting x squared minus 2x plus 1. There is my solution to that. Now, if I wanted to do the distributive property with this, I would still use the same method. We had talked about in previous videos, the distributive property is just when you break these parentheses apart into two separate pieces. So we're going to start by putting this blue x across this red x minus 1, and then our minus 1 over this red minus x minus 1 as well. So I'm going to start with x times x minus 1. And then I've got a minus 1 for my blue times x minus 1. And when I start multiplying these two things together, x times x is x squared. X times negative 1 is a negative 1x. Negative 1 times x is another negative 1x. And then, of course, negative 1 times a negative 1 is a positive 1. And you can, of course, see that these two things are exactly the same. Two different methods to solve the same problem. You pick and choose whatever makes sense to you. So what happens though if you now have a negative x as well? So the front end of this thing is negative. So look at this problem here. Again, we're not going to do a whole lot different than what we've done in the past. Let's color these up like we've been doing. Here's a purple and here's a green. So our purple is going to be x plus 3. I'm going to put my x plus 3 right here. And now I've got a negative x and a negative 5. So I'm just going to put a negative x and a negative 5 right there. Now when I multiply these two things together, x times negative x is a negative x squared. Let's make that our yellow. And then we've got negative x times a positive 3. So we're left with a negative 3x. Let's make that red. And then we have x times a negative 5. So we have a negative 5x. Let's make that one gray. And then finally, we have negative 5 times a positive 3, which is negative 15. We'll make that kind of a pinkish color there. So here we go. So when we simplify all this together, negative x squared minus 3x minus 5x minus 15. And then, of course, when we simplify, we're left with negative x squared minus 8x minus 15. Nothing's going to be any different, as we've seen before, if we've got our x and we have our negative x minus 5. Now, I will say, sometimes it's easier to put this one, to break this one apart than it is to do this one. You don't always have to break this one apart. And actually, let's do that. Let's break this one apart instead of this one. Just so you know, because this is, if we've got this piece times this piece, that's the same thing as if I were saying 2 times 3. Well, 2 times 3 is the same thing as 3 times 2. So it doesn't matter what order I'm actually going in. So I could break apart the green one. Let's do that. Let's do a negative x times x plus 3. And then we'll do a negative 5 times x plus 3. So now when we distribute negative x times x, we still have our negative x squared, negative x times 3, our negative 3x, negative 5 times x is our negative 5x, and negative 5 times 3 is our negative 15, and we can see that we are still ending up with the same thing. I hope anyway. Yes, we are, because if we weren't, we would definitely be in trouble. So, area model, distributive property. Doesn't matter if you've got positives or negatives. The important thing is that you're always keeping track of your positive and negative signs with the specific terms, and you're simplifying your like terms. I hope that was helpful. Give me a thumbs up if it was helpful, and I'll see you in the next video.